got a transfer switch here. This one is by Southwire, but any brand's transfer switch is going to function more or less the same way. The customer complaint on this one is that the transfer switch does not see the generator as priority when running. When running the generator, it stays on shore power. So our number one most likely cause for this is going to be that the generator circuit breaker is tripped. So on top of every generator, or sometimes under the hood of the generator, there's going to be a built-in circuit breaker, a nice high amperage circuit breaker. A lot of times if techs are working on any sort of electrical, they will turn that breaker off just as a safety precaution. A lot of times customers will turn it off if they're not using the generator. So it's a likely source of why we're not detecting the generator. But then the next thing we're going to want to do is confirm, do we actually have power at our transfer switch? So if we take a look at our overhead cam here, I've got our transfer switch open and we can see the inside where we've got these two great big contactors. I've got a little electrical line hooked up, and don't worry, I've got the end right here, so I'm not touching live electricity. Here you can see we've got our neutral line, this black line coming in. We are connected to 50 amp on this one, so we've also got our red line here, our line 2 of energy coming in. These are both of our hot lines. As you see, they match the colors on the other side of our contactor here. They match the gauge and the coloration on both sides of our transfer switch. We've got our ground here as well. So we've got our two different contactors in here. We've got our shore power side and we've got our generator side. We always want to make sure when we're testing, whichever one that we're testing, so for this customer complaint, we would be looking at the generator side. We want to test on this side, go from hot to neutral. Do we see 120 volts? If we're dealing with the 50 amp, we want to test both legs, and then you want to test across so that you see 240 volts when you're testing across this way. We want to make sure that we have good power coming into our contactors before we do anything else. Because if we don't have good power coming into our contactors, the problem's not the switch, it's before it. You want to make sure you got power in, and then you want to make sure you've got power across. So at that point, you're going to test for the same voltages, but on this side of our transfer switch. So we've got good power in, we've got good power across. Some of our bigger models are going to have another kind of little jumper down here before it goes out to the rest of the coach. If that's the case, we want to make sure we're testing that too. Make sure that we've got power across it. Good power in, good power across, good power out. Those are the three fundamental parts of a transfer switch that we need to worry about. All right, we're going to plug it in now, and we should see that contactor sink in. Now it can take up to a minute for these contactors to recognize good power, and that one just did. So now we're going to make sure that we've got power all the way throughout it. So I got my meter here set to AC volts, and I'm going to test from my hot to neutral. So I got my hot line 1 here, neutral line 1 here, and we see I've got 114 volts. Now I'm going to do the same test on my other side, 114 volts. So we've got power in, we've got power across. This transfer switch is working correctly. Now our next customer complaint that we have here is that they had the transfer switch not engaging on shore power because it was showing an open ground fault. An open ground fault usually indicates that your transfer switch, your automatic transfer switch, is intentionally not allowing power to pass through because it is detecting an open ground. It is trying to protect you from an electric shock. The first thing we want to do if our transfer switch is showing an open ground fault is test the pedestal that we're plugged into. Make sure that we don't have an open ground. And if it's a customer, they want to make sure that they are testing, have an electrician test their campsite. If this is at your service shop, you want to make sure to get maintenance out there so that they can verify everything's hooked up and wired correctly. I'm going to go ahead and unplug this, and then I'm going to simulate an open ground that you plug in on. With my power disconnected, I'm going to go over here and I am going to undo my ground. So now my incoming power does not have ground coming to it. I'm going to go here and I'm going to hook up with my transfer switch, and we should see one of our lights come on the circuit board. There we go. So we see this light came on. This means that the transfer switch has detected that it's got an open ground. It's not allowing power to pass through, as you can see. So the way that you would test for an open ground with your multimeter is that you're going to take a test and you're going to look at your voltage here. From hot to neutral, I see about 114 volts. But if I go and I test to my ground, from hot to ground, I see significantly less voltage. This is indicating to me that I have got an open ground here. I've got some voltage floating over to my ground, and that's what we don't want. If we've tested at the pedestal, we've made sure we don't have an open ground. We've tested here at our transfer switch and made sure that we've got good power coming in and the contactor still fails to transfer over power. At that point, we would be looking at replacing the transfer switch. What I want to really emphasize is that we've had a couple of reports written in to where people are saying, oh, I'm not passing voltage unless I am pushing down the contactor here. Please don't do that. Because what you see right here, if we look a couple inches this way, a couple inches that way, I've got my hot lines. There's a reason I'm holding it and doing it with my meter leads here and not with my fingers, because I am hot right now. I don't want to accidentally, while I'm playing around in here with this live transfer switch, touch my hand across the hot and neutral line. Now I've been electrocuted. We don't want that to happen. So please, do not play around with pressing down the contactor while it is active and while you're trying to get power across. Now sometimes the fault is not going to be quite as obvious as my ground being loose all the way up here like that. Sometimes it can be as simple as what I think was actually the case with this particular transfer switch. My little Wago right here. This side of it was not fully seated, so it may have had an intermittent ground fault because of that cable not being completely seated. Most electrical problems, especially in the RV world, can be boiled down to one of two things. Either a tripped breaker or a bad connection. And these transfer switches not only detect on the feed side of the transfer switch, they also detect on the output side of the transfer switch. So if we test good here, but we're not outputting good voltage or correct voltage here, we may have a connection problem that is not allowing enough voltage to pass through, and the transfer switch is not going to let it pass. So we always want to verify, do we have correct power coming to the device? And are our connections tight, clean, and ready to go?